All right, hello everyone. Welcome to my channel. This channel is educational in nature, and we look at a number of different things, although we've been pretty much focused on um, the reciprocal system of Dewey B. Larson for the last almost a year. Um, but we will be opening it up here in a few months and move into other subjects, but we want to cover it. We want to do a deep dive on this, especially since I really can't find any other sources that are really covering the reciprocal system of theory in any kind of detail. And so this is your one-stop shop for a universe of motion. And that's exactly right. Mr. Larson was an engineer who lived in the 20th century. By the way, today's video 337 on the reciprocal system here. And Mr. Larson, in about 1930, had a few epiphanies as he was working on a different scientific problem that he found would have been, his findings were much more potentially all-encompassing. And he answered the call, and he recognized he was kind of in over his head, maybe, but that he had to step it up to be able to understand the broad potential that he had uncovered. And it took about 25, almost 30 years to work out his ideas to the point where he could summarize them in two fundamental postulates. And then he took those two fundamental postulates and from them derived a theoretical universe. And then took that theoretical universe and kind of like compared it to the legacy scientists, their universe, which they had arrived at through their observations and measurements and hypotheses. And then he wrote up his findings in many books that he wrote between the years 1959 and when he died in 1990. That I guess also includes his posthumous work, Beyond Space and Time, that his wife published in 1995. Now, the basic thing that you should know about the reciprocal system is that it posits a universe of motion. The universe is made entirely and completely out of motion, not matter, not energy, not force or anything else, but motion. Matter, energy, and force are merely three different varieties of motion. And motion for Larson was the relationship between time and space. That leaves space and time as reciprocals, and they do not have any independent existence. They only exist together in motion. Motion can be thought of as a fraction with time or space as the numerator, space or time as the denominator, such as speed. Speed is probably the most basic kind of motion that we look at, and speed is described as space over time. The car is moving 20 miles per hour, 20 miles of space in 1 hour of time, space over time. Also acceleration. I dropped the rock out the window and it fell at 9.8 meters per second squared. 9.8 meters of space in 1 second squared of time. So that is space over time squared. Energy. Energy is time over space. It took me 20 minutes to move that thing 5 feet. That is 20 minutes of time in 5 feet of space, time over space, and so on and so forth. All of our basic scientific quantities are forms of motion. Matter, energy, force, acceleration, electrical resistance, electrical capacitance, electric current, electric charge, pressure, magnetic flux. These are all viscosity. These are all forms of motion and can be reckoned in space and time terms only. Now, when we understand space and time, it's where we get kind of into Larson's first postulate. Basically, as reciprocals, any quality that adheres to space also adheres to time, and vice versa. Now, one thing that we generally know about space is that it is three-dimensional, what Larson calls coordinate space, X, Y, Z coordinates. So too, therefore, time is also three-dimensional, or has its three-dimensional aspect, which Larson refers to as coordinate time. The main thing that we know about time is that it is always getting later and later and later and later. It flows or it progresses, but in no specific direction. We don't say that time is flowing to the north, or time is flowing that way, or anything like that. We just say that time is always getting later and later and later. So, by the reciprocal postulate, space also flows like that. You think of it as time is always, or space is always getting farther and farther and farther apart. And you could envision this using a balloon with dots on it. You take the balloon and you blow it up. All of the dots are moving away from each other. The space between the dots is getting farther and farther and farther apart. But they're not moving in any specific direction. Each dot is moving away from each other dot. And the further away they are, the faster they're moving away from each other. And that motion does not acquire a direction until you assign a reference point. When you decide that one specific dot is motionless, then you can start assigning directions. Well, that dot is moving north away from my reference point. That dot is moving south by southwest away from my reference point. So the direction of the motion, the vectorial aspect of the motion, is a product of the reference system, or assigning a reference point, not from the motion itself. The motion itself has no direction. This was also observed by the Hubble telescope, that observed that all of the distant galaxies are moving away from each other. And the further away they are, the faster they are moving away from each other. So unless we're willing to, contend that our galaxy is at the center of the universe, then we would have to admit that our galaxy is also participating in the motion away from all other galaxies. All of the galaxies are moving away from all of the other galaxies, but in no specific direction. This is what Larson calls clock space. So there's clock time. The clock is always getting later and later and later. And clock space. Everything is always getting farther and farther and farther apart. And then both time and space come only in discrete units. There's a minimum unit of time that you must have to have any time. And there's a minimum unit of space that you must have in order to have any space. If you don't have that full unit, then you don't have jack. And also, if you have 1 unit of space in 1 unit of time, recalling that space over time is speed. 1 unit of space in 1 unit of time is the speed of light, which Larson refers to as unit speed. So this speed, 1 over 1 equals 1, is the background of this universe. You could think of it, the origin, the first principle, the ether, the 0 point, the reference system, or the progression of the reference system. And the neutral point or null point. This also means that half of the universe is moving faster than the speed of light, which is blasphemous to your Einsteinians out there and your 20th century theorists, scientific theorists, who would claim that the speed of light is the maximum speed of the universe. Larson is showing that the speed of light is the midpoint of the universe, and Einstein's statement only applies or only uncovers half of this universe, the half that's moving slower than the speed of light, which Larson refers to as the material sector. The half that's moving faster than the speed of light, Larson calls that the cosmic sector. And fortunately, they are reciprocals of one another. So whatever pertains to the material sector also pertains to the cosmic sector, only in reverse. So you have to invert the roles of space and time. So in the material sector, we see the familiar roles of three-dimensional space and clock time. The clock is getting later and later and later. But if we cross that unit speed boundary and move into the cosmic sector, then we would observe coordinate time, 3 dimensions of time, and clock space. Space would always be getting further and further and further apart. So that's kind of how it gets set up. And then the second postulate, which is not as significant, basically says that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean. Actually, some people have tried to take Larson to task about the Euclidean geometry involved in the universe, and that is just a subset of the real geometry of the universe, which is projective geometry. And so we will get into exploring those ideas at a later time. But for today, we are on our 6th episode of going over Larson's paper that is called The Mechanism of the Universe. And I think he wrote this back in the 70s, 76 maybe. And he might have given it as a paper. But so if you want to get this from the start, you want to go back 5 episodes and go through the paper from there. But we'll start here. He's going over, this paper is basically on cosmology, how the universe formed, where it came from, what are the basic principles, how, where's it headed, and things like that. And he's looked at various other theories of legacy scientists, such as the Big Bang theory, the oscillating universe theory, and the steady state universe theory. And he's kind of attempting to place his theoretical universe into that context. And he just got done talking about creation. Maybe I'll just read the last few sentences of his last paragraph to transition into this. I will say that our findings do not affect the creation issue one way or the other. If the universe of motion came into being through an act of creation, then space and time were the entities that were created. There could be nothing before time existed, and if it came into existence as a result of an act of creation, the universe that was created could just as well be cyclic as open-ended. Having established the general nature of the cosmic cycle, let us now take a closer look at the principal features. One of the advantages of a general physical theory, such as the reciprocal system, is that the deductions we make from it do not have to be confined to generalities. We can go into as much detail as we wish, or in this case, as much as we have room for. The matter ejected from the cosmic sector arrives in the material sector in the form of atoms, of the cosmic elements, together with subatomic particles. The current belief is that these incoming particles, the cosmic rays as they are called, are atoms of the material elements. But the available means of identifying the original cosmic rays are not capable of distinguishing between the cosmic and material atoms. Furthermore, the subsequent behavior of these particles shows that they are not ordinary material elements. If they were, they would maintain their identities, at least until they made some violent contact with other matter. But this is not what happens. If these atoms do not make contact quickly, they disintegrate spontaneously. This is not the place to give a detailed account of the complex process by which cosmic elements are transformed into structures that are compatible with the material environment. I will merely say that the end product is hydrogen, and this new hydrogen is the raw material from which the new structures of the material sector are built. Now, just recall, when he says cosmic elements, he's basically saying atoms from the cosmic sector. In the material sector, we have material atoms. And then in that cosmic sector, the sector that's moving faster than the speed of light, we have cosmic elements, which legacy science would have called antimatter. Okay, it is recognized by the astronomers that any evolutionary theory of the universe must regard the aggregates of matter, such as stars and galaxies, as having been formed by condensation from dispersed matter. But just how this can take place is a difficult question that, as Gold and Hoyle pointed out in the statement that I quoted earlier, they prefer to avoid. But the continual arrival of new supplies of hydrogen derived by modification of the cosmic matter received from the cosmic sector provides the answer to this problem. Let us consider a spherical volume of space containing a uniform distribution of hydrogen atoms and subatomic particles. These particles, small as they are subject to the same two basic forces or motions that account for the translational behavior of the galaxies. The outward progression of the reference system carries each particle away from all others, while at the same time, the gravitational motion carries all of them inward toward each other. Early in this paper, Larson established that gravitation is the opposite force of the progression. And so this would be you taking your balloon with dots on it and sucking it in, moving all of the dots toward each other. So gravitation is not really a force the way that we think of it as like one body is being attracted to the other, to another body. It is all bodies moving inward toward each other. And gravitation doesn't, attain a force field or a direction until you assign a reference point, until you determine that one of the points is motionless. And then all of the other points are moving toward that point. And then you can assign a direction to each one. But but that disguises the fact that the dot that you determine to be the reference point or the motionless point is really moving toward um, all the other dots at the same time. So the motion of gravitation is an inward scalar motion. All of the dots are moving inward toward all other dots. Okay. The outward progression of the reference system carries each particle away from all others, while at the same time the gravitational motion carries all of them inward toward each other. The outermost particles of this spherical volume of matter are subject to the gravitational effect of the entire mass, as well as the interactions with their immediate neighbors. But in relatively small volumes, the progression still predominates, and the aggregate tends to expand. As larger and larger volumes are taken into consideration, however, the mass and consequently the total inward force increases as the third power of the radius, whereas the effect of distance is a second power function. At some very large volume, therefore, the total gravitational motion of the outer particles exceeds the progression, and the entire aggregate of diffuse matter arrives at an equilibrium between the inward and the outward motions. Such an aggregate still has no unbalanced force that would cause it to contract. But the continual introduction of additional matter from the cosmic sector changes the situation, inasmuch as it strengthens the gravitational forces and moves the equilibrium inward. As this contraction of the volume occupied by the aggregate continues, and the density of the enclosed matter increases, local aggregates begin to build up within the occupied volume, and the ultimate result is a globular cluster in which 1 million or more stars from a spherical aggregate, in which 1 million or more stars form a spherical aggregate. The globular clusters have been an astronomical puzzle of long standing, as it is quite evident that they are stable and long-lived structures, but no adequate explanation has been available as to why the gravitational forces that hold such a cluster together do not cause its constituent stars to coalesce into one single mass. The progression of the natural reference system supplies the answer to this problem. The globular cluster is still subject to the same considerations as the spherical aggregate of diffuse matter from which it was formed. Like the interior particles of the diffuse aggregate, each of the stars in the interior of the cluster has a net outward motion. But the outer stars have net inward motions, and an equilibrium is established between these inward and outward motions. Okay, I think we're going to leave it right there. For Larson, the globular cluster is a major thing, and the globular cluster is kind of like halfway between, or halfway toward a galaxy, but it forms out of basically a diffuse. The globular cluster is really kind of forming at the same time as stars are forming, and as stars coalesce, then also globular clusters start to form. I guess he explained it better than I did right there, but we will look into in the next episode, I guess, how these stars and these globular clusters eventually form galaxies, and then what happens to the galaxies as they age and get older. And we're going to finish this paper tomorrow, "The Mechanism of the Universe" by Dewey B. Larson. And thanks for tuning in today. Have a great day.